So the ignition system on this 1999 Jeep Grand Cherokee, we have the 4.7 V8 and it uses individually fired coils. These are the sensors that go into the ignition timing. You have the PCM, which determines everything, and it uses the inputs of the crank, cam, map, throttle position, idle air control, and ECT sensors. The spark plugs should have a resistance of 6,000 to 20,000 ohms. The ignition coils have a primary resistance of 0.6 to 0.9 ohms and a secondary resistance of 6,000 to 9,000 ohms.
Alrighty, so right now we're just measuring the primary side of our ignition coil. You can see right now we're measuring 0.8 to 0.7 ohms, which is within specification. And now we're going to measure the secondary coil. So going into the bottom and the top there. And we're getting 7.3 kilo ohms. And our specification for both of those, it was 0.6 to 0.9, and then 0.6, and then 6 to 9 kilo ohms for the secondary side, and we're getting 7.3, which is in spec. As you can see here, the gap for the spark plug is 40 thousandths, which is the specification, and all of the spark plugs are gapped to 40. So here we are on our 1999 Jeep Cherokee. Right now we're measuring the primary side coil voltage of our ignition coil. See, we've got how it's kind of grown here. Coming right back into our attenuator, and then into our picoscope here. And right now here you can see the primary ignition coil waveform here. You can see that the voltage spike here is getting around to 80 volts. So it's quite a bit of voltage here. Right now I'm going to go ahead and measure the dwell time. So it looks like our dwell time right now is around 3.6 milliseconds. So that's the amount of time that the coil is actually charging up. And then the spike there is our spark event. Alrighty, back on our Jeep Liberty here. We've got our inductive amperage clamp hooked around the exact same wire that we were probing on this ignition coil here. We have this wire also coming back to the scope, and right now here you can see the amperage measurement. We have the scale set for plus or minus 2 amps. We have that there linked up with our voltage event. You can see exactly when the coil actually starts charging and the amount of current flow that is permitted to flow through the coil during its charging phase or dwell time. And then you can see the amperage drop there, and that correlates with the spark line. Alrighty, so here we've got our picoscope set up, and we have included the in the yellow here the crankshaft position sensor information. So as you can see here, we have our spark event, and it's happening just a little bit after that tooth on the crankshaft. And so right now I'm going to just increase the engine RPM to see if the dwell time or if the spark advance changes at all. So even as the frequency of the increases for the crankshaft position sensor signal, you can see that it looks like the spark advance and the dwell time stayed pretty similar. So here you can see we've got some PIDs pulled up for the 99 Jeep Cherokee, and you can see that we do have an ignition timing advance PID there. And you want to go ahead? You can actually you can see the PID change there. And so previously, even though we were increasing the RPM, we couldn't see any difference with the timing advance. We couldn't see if it was advancing or not because the fidelity of the scope, you have to really zoom in and actually use the measurements to determine if there is a change from cycle to cycle. But this confirms that there is timing advanced upon throttle.